Hopefully you guys are okay at making equations from a word problem. It'd be nice if my screen would work. It was fine on my screen and still up there. There it goes. Hopefully you've learned this skill already in your algebra classes. This is a very common way to ask these kind of questions, where you're given, statements and you have to make a system of equations from the statements. So let's just read the whole thing. It says a local band sells out for their concert. There are 1,175 tickets total. And their total purse, the money they make, is $28,112.50. The tickets are priced $20 for all students, $22.50 for children, $29 for adults. If the band sold twice as many adults as children tickets, how many of each type was sold? So in this case, how many different variables are there? That's what I always do first. 3. And what are the 3 variables?
Student, adult, child.
So we're talking about the number of student ticks. So I'm going to let that be X. I'm going to let Y be the number of children tickets. And I'm going to let Z be equal to the number of adult tickets. So because I have 3 variables, I need at least 3 equations in order to solve the system. Okay, so does anybody see an equation they could write? This one always messes me up. If the band sells twice as many adults as children, which number is bigger? The adult tickets is bigger. So Z has to equal, right, if I double the number of children's tickets, it should be equal to the number of adult tickets. That's the way I have to say that to get that right in my head. So there is one equation. Anybody see another equation we could use?
X plus Y plus Z equals 1,075.
Yes, so the total number of tickets has to be 1,175. If I add up the 3 different kinds of tickets, it has to equal 1,175. It's the second one. And the third one?
20X plus 2250Y plus 29Z equals 28,000 and whatever the rest of it.
That's it. So if I take the number of adults tickets and multiply it by 20, because I made 20 for every adult ticket, and then 22.50 for every children's tickets, student ticket, children's ticket, $29 times Z for how many adult tickets are sold. The total amount of money I should have made is $28,112.50. Any questions about finding those equations? And so before I can put this in my calculator, what has to be done? They need to all match the same form, standard form. So you need your X's to be in the first column. You need your Y's to be in the second column, Z's in the third column, constants on the other side of the equation side. So the first 2 equations are fine. The bottom one is not. So I would need to manipulate this to look like negative 2y plus z equals 0. Or you could have put in 2y minus z equals 0. It does not matter. They both would work. you solve it from there, put it in your matrices. I don't really want to take time to do it if everybody feels good about it. Okay. So first thing we're going to do, we're going to start with adding and subtracting matrices. So it says here, we use matrices to list data or to represent systems. Because the entries are numbers, we can perform operations on matrices. We can add or subtract matrices by adding or subtracting the corresponding entries. Do this, the entries must correspond. Therefore, addition and subtraction of matrices is only possible when the matrices have the exact same dimensions. We can add or subtract 3x3s with another 3x3, but we can't add or subtract a 2x3 with a 3x3 because the entries won't match up. So, like, you could do this in your calculator too. But to me, that's a waste of time. It'd take way more time to put this in your calculator and then get the answer than it would be like this. Does everyone see that these are the same dimensions? They're both 2x2 matrices. So if you want to add the matrices, just add the corresponding entries. So 4 and 5 add to be 9. 1 and 9, 10. 3 and 0, 3. 2 and 7, 9. Any questions? Does anybody want me to show you how to do this in your calculator? Is that worth it? I hope not. Okay, try the... Essentially distribute that negative. That's 2 minus 6 is negative 4. Negative 10 minus 10 is negative 20. Negative 2 minus negative 2 is 0. 14 minus 0, 14. 12 minus negative 12 is 24. 10 minus negative 4 is 14. 4 minus negative 5 is 9. Negative 2 minus 2 is negative 4. 2 minus negative 2 is positive 4. So in physics, there are different things in dimensional analysis. So like the main thing I want to talk about is the difference between a vector and a scalar. Vectors have two quantities. They have a magnitude and they have a direction. So you could think about, like with your car, if we talk about the velocity of your car, the velocity has two values. The magnitude of the velocity, that would be basically your speed. So if I was traveling 65 miles an hour, that is your magnitude. But with a vector, it also has direction. So there's a difference between 65 miles per hour north and 65 miles per hour south, right? Because you're going different places. So direction matters with a vector. With a scalar, direction does not matter. All that matters is the speed. So for instance, speed on its own is a scalar quantity, whereas velocity is a vector quantity. Doesn't really matter, but I wanted you to at least have some idea if you ever came across that in another classroom, another education setting. That way you could say, I've never heard that. And they say, well, where are you from? That'd be not good, right? So maybe you can at least fake it for a second. Or not. You probably just won't remember you had this conversation. If I read this, there are many situations in which we need to multiply a matrix by a constant called a scalar. Recall, a scalar is a real number quantity that has magnitude but no direction. I wish I'd have read that earlier. For example, time, temperature, and distance are scalar quantities. The process of scalar multiplication involves multiplying each entry in a matrix by a scalar. Scalar multiple is any entry of a matrix that results from the scalar multiplication. So here I've got a matrix, and he wants me to multiply it by the scalar 5. Well, you're essentially distributing. So if I multiply all of those by 5, that's 40, 5, 25, 20. Questions there? Next, scalar multiplication. This time it's -2. So that gives me a -8, a -2, a -6, a -4. Questions there? All right, here's maybe our first interesting problem. Find 3a plus 2b. So this has both operations that we've dealt with so far. We have a scalar multiplication, we have another scalar multiplication, and then I need to add the matrices. Well, the order of operations still holds. So you need to do the multiplication first. So if I multiply those, first one by 3, that's 3, -6, 0, 0, -3, 6, 12, 9, -18. And then we're going to add it to, multiply the second matrix by 2. So that's -2, 4, 2, 0, -6, 4, 0, 2, -8. Is okay so far? And now they need to add them. Remember, you can only add if they have the same dimensions, and luckily these do. They're both 3 by 3s. So then just combining like terms. 3 minus 2 is 1. -6 and 4 is -2. 0 and 2. 0 and 0. -3, -6. 6 and 4. 12 and 0. 9 and 2. -18 and -8. This one, depending on how quickly you can do multiplication and addition, this one might be quicker for you in a calculator. It's not for me. But that one's more, could be quicker for some. Don't need to show you how to do that in a calculator yet. I know the next ones I'm going to show you. I'm going to do them all without a calculator first, and then we'll put them in a calculator. Okay. So when you add and subtract matrices, they must have the exact same dimensions in order to add them or subtract them. But when we multiply a matrix by a matrix, so this is essentially multiplying a vector by a vector. Right? That's what's happening here. They don't have to have the exact same dimensions. What does have to happen is the columns from the first matrix must match the rows from the second matrix. So my hint here that I always do, before I carry out the multiplication, I always write the dimensions and then see if those middle ones match. So you can see there they've got an example. If we had to multiply A by B, and they tell me A is a 2 by 3 matrix and B is a 3 by 3 matrix, I can multiply A times B because the middle dimensions match. We follow that? That's when you can do the multiplication. Now, the next thing I think is important is knowing what your resultant looks like. So look at what's left over, 2 and 3. That means after I have done the multiplication, my resultant vector should be 2 rows, 3 columns. Because those are the values that are left over, that are not used. And so when I do these multiplications, I always write out my vector like this first before I do the multiplication. Because you'll see it's very easy to get confused with what your resultant vector should look like if you go into it willy-nilly and not having a game plan on the front end. Which I know is weird for me to say because I am the most willy-nilly math person ever. But these can get confusing if you don't do it that way. So A times B works. Okay, what if I tried to do B times A? What were the dimensions of B? 3 by 3. The dimensions of A is... So could I multiply B by A? No. So this is not possible. So the main important thing to realize there is that multiplication of matrices is not... It's not commutative. Thank you. The long word that was coming to my head was converse. And I said, it's not converse. It's not commutative. I can't multiply matrices in any order like you can with integers or whole numbers. So just beware of that. So here it tells me to multiply the two matrices. Well, it doesn't tell me the order to multiply them, so I'm just going to assume it should be A times B. On your homeworks, it definitely should spell it out and tell you. So again, first thing I would do, I would make sure that this would happen, or this could work. So A is a 2 by 2, B is a 2 by 2. So is the multiplication possible? Yes. What does the resultant vector look like? It's still a 2 by 2. Okay? Still a 2 by 2. So I'm going to go ahead and mark that off because like I said, it's very easy to get confused if you don't. Now, which dimension are we keeping from A? If you think about these are the dimensions. We are keeping the rows from A and the columns from B. So when we do the multiplication, we want to multiply the rows from A by the columns from B. So I'm going to multiply the first row in A by the first column in B. And guess what position that goes into? First row, first column. Because I multiplied the first row by the first column. So this would be 5 times 1 is 5. 2 times 7 is 14. To be okay with that? Then I'm going to multiply the first row by the second column. And guess what position that goes into? First row, second column. Right? I mean, I have to say that to myself to keep myself straight. First row by the second column goes in the first row, second column. 1 times 6 is 6. 2 times 8 is 16. Next, I'm going to multiply the second row by the first column. And that's going to go in the second row, first column. 3 times 5 is 15. 4 times 7 is 28. And then lastly, the second row by the second column goes in the second row, second column. 3 times 6 is 18. 4 times 8 is 32. And now then go ahead and do the simplification. So this is 19, 22, 43, 50. Finished. A times B. So A, these always seem to throw people off. What are the dimensions of A? It is a 4 by 1. Anytime there's a 1 row or a 1 column, people seem to get confused. What are the dimensions of B? So 1 by 4. So can I do A times B? Yes. What's its final dimensions? It's a 4 by 4. Man. I don't know. I probably wouldn't. So I'm going to multiply the rows of A by the columns of B. So 0 times 0 is 0. That's first row, first column. First row, second column is 0. First row, third column is 0. First row, fourth column is 0. We following what goes where? Now, what's going to happen here if I multiply the next one, which is row 2? They're all going to be zeros, right? We saw that in the first row. If I go to the third row, 2 times 0, 0. 2 times 1, 2. 2 times 2, 2 times 2. 1 times 0, 1 times 1. 1 times 2, 1 times 2. So again, I don't know. It'd be close. If it's close, I normally go no calculator. I think that's real close. So we just wait. So right there's the answer to A times B. Questions there? Okay, now what if I do B times A? First, is it doable? B is a 1 by 4. A is a 4 by 1. It is doable. What's my final answer? So 1 by 1. I'm going to get a single number answer. So I need to multiply the rows from B by the columns from A. So this would be 0, 0, 4, and 2. Yep. 4 and 2 is 6. I need to write all that out like I did before. 0 plus 0 plus 4 plus 2. Isn't that crazy? The same two matrices multiplied together in different order give vastly different answers.